In this last video, we will be solving question 5, which is to find the reading on a scale for a situation as described here. So what we are doing in this situation is we're taking our chromium block, we're hooking it to a spring scale similar to what we had before, and putting it into an ethanol container and holding it there. So this is going to be a case where, since we're interested in forces here, we are probably going to want to make a free body diagram. Before we did this and found that it wasn't helpful for that particular case, but now we know one more thing. We know the buoyant force, which means we should be able to have enough information to solve this using a free body diagram. So we'll get started with that process. We set up a diagram where that will represent our block. We can think about the different forces acting on it. That would include gravity, also known as its weight. So that would be gravity or weight. We also have that buoyancy. We found more about that in the last point. And finally, we've got the scale here, the spring scale holding it up. So let's take account of what we've done so far. We found that the gravity force, or the weight force, this is something that was given with the problem, is 600 newtons. That's how much we know this thing weighs. And that will be directed downward, so we'll make it negative here. The buoyancy was solved for in the last part of the problem, which gave us 65.8 newtons. And we know that would be a positive force because it's as a buoyancy force directed upwards. We also have the scale here, which is exerting some kind of force, and that's what we're going to want to find and figure out what reading we should expect on the scale. So with this alone, we don't have enough information to solve for the scale force, but if we think about net force, that can help us. That force here can be found because the scale will be holding that block in a constant position. We'll be holding it in the same place, which means it will be staying at rest and therefore have no net force acting on it. Because we have two of the three forces and the overall net force, we should be able to solve for the remaining force. We can do this by using our definition of net force, which says that net force is the sum of all the individual component forces acting on an object. So we can set up that sum as scale, the one that we're missing, plus the ones we know, so 65.8 newtons for the buoyant force, and the negative 600 newtons for the weight. These should all add up to our net force, which we set as 0 because it's not accelerating. A little bit of combination here to figure out what's going on. And so we'll end up with scale minus something, and it'll be about 534.2 newtons. It'll still be equal to 0 newtons at the point. And then we'll have to use our properties of algebra to solve, putting the 534.2 newtons sides to isolate the scale force that we are trying to find. Once we do so, we will get that scale is equal to positive 534.9, or 534.2 newtons. Because we said this is what this is going to be equivalent to what the spring scale reads, this will be our answer for that last part. So if we think about what's going on here, this scale is reading something less than 600 newtons. If we were to just put this block on the scale in open air, it should read its actual weight, which would be 600 newtons. So because we put it in this fluid here, the ethanol, that has this extra buoyant force acting on it, the reading on the scale is going to be less. This is because the buoyancy here as an upward force cancels out some of the weight, so the scale only has to counter the remaining part of the weight, rather than the full weight as it would have to do in open air. This takes us through the full problem here, and so I hope this video was helpful, and good luck with the rest of your studying.